So as you just saw, a ball has a mass of 0.625 kilograms, and it's going east at 5 meters per second when it strikes ball B, which has a mass of 0.45 kilograms, which is going west at 1.8 meters per second. After the two balls collide, ball A leaves the collision going 1.5 meters per second north, 60 degrees east. So what that means is ball A was going like this, and then after colliding, it took off at this trajectory just a little bit slower. Ball B was approaching ball A, and ball B was going a little bit slower and had a little bit less mass. That was the smaller ball. And the question is, with what trajectory, with what velocity will ball B leave the collision? So this is the point of the collision. Ball A came in and then took off this way. Which way is ball B going to end up going? To solve this problem, we're going to find the total momentum in the system before the collision and know that that's going to be the same momentum after the collision. So this is before. So before the collision, our total momentum is the momentum of ball A plus the momentum of ball B. Ball A, with its mass of 0.6 and its velocity of 5, had a momentum equal to 0.625 times 5, and that was going east. So ball A had a momentum of 3.125 kilogram meters per second east. Ball B was heading west. Its momentum was 0.45 kilograms times 1.8 meters per second west. So ball B had momentum of 0.81 west. The total momentum before the collision is the momentum we get when we add those together. Now, I'm going to actually subtract because one of these is going east and the other is going west. So our total momentum is 3.125 east minus 0.81 east. Remember, a positive 0.81 west is a negative 0.81 east. So the total momentum in the system is 2.315 kilogram meters per second east. That's the total momentum we get when we consider the heavy ball heading east and the lighter ball heading west, and the lighter ball is going a little bit slower. After the collision, the total momentum is going to be the same. Momentum is conserved through a collision. That's why it's so useful in these questions. So after the collision, we have 2.315 kilogram meters per second east of momentum. And the total momentum is going to be equal to the sum of the objects involves momentum. So that means the total momentum is the momentum of ball A plus the momentum of ball B after the collision. The momentum of ball B is unknown, but it'll be equal to the total momentum minus the momentum of ball A. Now, after the collision, let me show you the question again. Ball A, after the collision, has a velocity of 1.5 meters per second, and it's going north 60 degree east. So if you start at where I've got the A here, you can see that after the collision, it's angled upwards. That's north 60 degree east. It's actually 30 degrees north of east. So we call that, we state north and south first, and then east and west second. So we call that north 60 degrees east. So the momentum of ball A is we have a mass of 0.625 kilograms and a velocity of 1.5 meters per second north 60 degrees east. That makes the momentum of ball A 0.9375 north 60 east. And I'm going to break that into components. If I multiply that magnitude 0.93, if I multiply it by the cosine of 60, that's going to tell me how much momentum I have going north. And when I multiply it by the sine of 60, it's going to tell me how much momentum I have going east. So I've got 0.9375 times 60 degrees cosine, and that gives me 0.469 kilogram meters per second north. And then when I multiply that by 60 degrees sine, that's going to give me 0.81 kilogram meters per second east. Let me just double check that. Yeah. So remember, the momentum of ball B is going to be the total momentum minus the momentum of ball A. And the total momentum is 2.315 kilogram meters per second east. And I'm going to subtract from that the momentum of ball A. So I'm going to subtract from that 0.469 north. And I'm going to also subtract from that 0.81 east. So these two values here represent the momentum of ball A, which I'm subtracting from the total momentum, because if you're to rearrange that, the momentum of ball A plus the momentum of ball B has to be our total momentum. So the momentum of ball B is 2.315 minus 0.81, and that gives me 1.5 kilogram meters per second east. And from that, I'm subtracting 0.469 kilogram meters per second north, which is the same as adding 0.469 kilogram meters per second south. Now, to put all of that together, the magnitude of the momentum is the square root of 1.5 squared plus 0.469 squared. And that's going to be southeast. And the angle between them is going to be the inverse tan of 1.5 divided by 0.469. And if you go ahead and do that, you'll end up with 72.6 degrees. So let me just quickly calculate this. Gives us the square root of 1.5 squared plus 0.469 squared. Gives the square root of 2.47. So that's 1.57 kilogram meters per second south, 72.6 degrees east. Now that's actually more east than south, so you may want to write that. It's not traditional to write it this way, but it certainly helps you visualize it. That is east, about 17 degrees towards the south. So that means that we're going southeast. So that ball B, after colliding, must have bounced back that way, mostly east. And at the end of the video, I'll show you the balls colliding again, so you can see that that's what happened. Now keep in mind, I found the momentum. This is the momentum of ball B, not the velocity. That's the momentum of ball B. So to find the velocity is momentum divided by mass. So I'm going to take my 1.57 kilogram meters per second and divide that by the mass of ball B, which was 0.45. And so that's going to give me 1.57 divided by 0.45, which is 3.49. 3.49 south, 72.6 east. And that's in meters per second. Okay, so just allow me to recap. We had a ball that was going east pretty fast, and then another ball with less mass was going west, a bit slower. Upon colliding, if we knew that the eastward ball took off 30 degrees from the east, so that's our north 60 east means east 30 towards the north. If it took off at 1.5 meters per second, so this is ball A, it took off at this angle. Just from knowing that, we could determine the velocity with which the second ball must have left, because the total momentum before the collision has to be the same as the total momentum after. By adding the two momentums, the momentums of each ball before the collision, we found our total momentum. We then immediately said that that was the total momentum after the collision as well. And then having been given how ball A responded to the collision, we could calculate its momentum and subtract it from the total momentum to get the momentum of ball B. Now, when I use the words adding and subtracting, these are vectors, so we split them into components and add or subtract them component by component. Now, remember this last step. Once you know the momentum of the second ball, you've got to divide by its mass to get its velocity. Now, I'll just show you that video again and see if that matches the the math that describes it.